Okay, hi. This is a recorded lesson for the Monday Zoom, right? The paper one revision that we have gone through last Monday on Raffles SA2 2020. Okay, because I forgot to press the button when we were doing the Zoom recording. So as a result, I have to record the lesson again, right? I have to run through the lesson and then do a recording so that you can watch it, right? Watch it, especially for those who have missed the lesson on last Monday. Okay, so just a gentle reminder. All right, if you see me online and before we start the lesson on Monday, do let me know that I need to record, to press a button, right? Press a button to record the lesson. Otherwise, otherwise we don't have any recording for you. Okay, so let's look at let's run through again. Okay, let's run through question 1 all the way to question 30. So but this time in my lesson here, in my recorded lesson, I will try to talk more, right? Talk more about how we can solve, right? Compared to on Monday, where we have only about 1 hour. So I'll try to explain a bit more, right? So that you have you can learn more things, right? And you can understand better. So let's look at question 1. How do you express 35 kilogram and 9 grams in kilograms? You will have to change the whole, you have to change this into grams. All right, and once you change into grams, that will be 35,009 grams. And how to change into kilogram? Okay, to change into kilogram, there is a small unit to big unit. So from small to big, you have to divide. All right, to convert from small unit to big unit, you have to divide by 1,000. Why do you divide by 1,000? Because 1 kilogram is 1,000 grams. So you have to divide by 1,000, but without calculator, how to divide? Change the whole number into a decimal. All right, and then shift the decimal point to the left 3 times. 1, 2, and 3. All right, why 3 times? Because thousands have 3 zeros. And where do you put the decimal point? Above the arrowhead. So how many kilogram? That will be 35.009 kilogram. So your answer should be number 1. Okay, number 1. Okay, let's go to number 2. Which digits is in the hundreds place? Now there's a TH. So where is that place value? Now, the digits in front of the decimal point is your whole number. Like these are ones, okay? 7 ones, and then this will be your tens, and this will be your hundreds. So when you see the digits, all right, or the digits in front of the decimal point, these are whole numbers, and the digits behind the decimal point, that will be your decimal already. So this is your tenth, okay, tenth, and then it gets bigger, which is the 100, okay, the 100. So now you can see which digit is in the hundreds, which is the digit 8. So digit 8 is in the hundreds place. And of course, your digit 5 will be the thousand, right? Thousand place. Okay. All right. So the answer will be number 3. Okay. So let's go to question number 3, shortcut. So for question number 3, there's a shortcut. Like some of you, what you would have done is you take 5 divide by 8. So when there's a fraction, it also means dividing. It means that 5 over 8 or 5 divided by 8. So fraction means divide. Okay, but is there a shortcut to do faster? Yeah, just take note of the special number 8 and make the 8 into 1,000. All right, to change a fraction into a decimal, you just have to try to see whether can you change the denominator into a 10 or 100 or 1,000. Because if you can change into 10, 100 or 1,000, then it's very easy to get the decimal. For example, for this fraction, I cannot change into a 10, I cannot change into 100, but I can change into 1,000. So the 8 is a special digit, right? Special number. So 8 times 125 is 1,000, and then 5 times 125 will be okay. So you do your working, and you will get 625. So 625 over 1,000. So how do you convert this into a decimal? So your decimal will be 0.625. So that's why we always try to change the decimal into a 10, 100 or 1,000 so that we can convert to decimal easier. So the answer is number 4. Okay, next one, question number 4. The mass of one box of chocolate, one box of cookies is 0.59 kg. What is the total mass of 30 boxes of cookies? Now, those of you who have done 0.59 and you multiply by 30 is actually a little hard. Okay, can we do something easier? Yes, we can. You just have to take 0.59 times 30. 30, you break up into number bonds, 3 times 10. And then you can multiply this, right? 0.59 times 3. So I will skip the working because I'm sure you can do this yourself. So you will get 1.77. So if you do correctly, After you multiply, you will have 1.77 times 10, and then you just have to shift the decimal point to the right, because when you times, the decimal point goes to the right after one digit, because there is only 1 0, right? So now you have 17.7. So what is the total mass of 30 cookies, which is 17.7 or 17.70 kilogram? So the answer is number 3. Okay, let's go to the next one. Question number 5. Okay, now, common mistake. What is a common mistake? Some of you who have made a mistake is because you take 6 kilogram and you minus 5 over 9. But why cannot do that? Now, Mr. Tan had 6 kg. There's a kg there, and he used 5 over 9 of each. If you look at this fraction, there is no kg. That's why you cannot take 6 kilogram minus 5 over 9. They are different. So he used 5 over 9 of each to bake some cakes. How much had he left? So you should try to find how much he used. So this fraction is talking about each, which is the sugar. So he used 5 over 9 of his times. And each refers to the sugar, which is 6 kilogram. So how much did he use? So you change the whole number into a fraction. Then you cancel. So you divide by 3. Divide by 3, you get 3. And then 6 divided by 3, you get 2. And then you have 5 times 2, that'll be 10. And 3 times 1 will be 3. And then you change it to a mixed number. And you have 3 and 1 over 3 kilogram. So how much did he use? 3 and 1/3 kilogram. And then how do you get how much left? You take 6 kilogram minus 3 and 1/3 kilogram. So for this part, some of you don't know how to subtract. So how do you subtract? You borrow 1 whole from 6, and the 1 whole convert to a fraction, which has the same denominator, which is 3 over 3. And now you can minus 3 and 1/3. So you take out 1 whole, and you convert the 1 whole into a fraction with the same denominator, so that you can minus the fractions. So 5 whole minus 3 wholes will be 2 wholes. Then 3 minus 1 will be 2/3, right? So what is the leftover? 2 and 2/3 kilogram of sugar left, which is answer number 3. Yep. Okay, let's go to number 6. Now, what is the value of angle X? So if you look at angle X, property here is angle at a point. So when you add all the angles together, that'll be 360 degrees. So to get angle X, you just take 145 degrees plus 86 and plus 69. All right, add all these numbers together. Okay, so let's add them, and you will get 300 degrees. And then angle at the point is 360 degrees minus 300, and you will get 60 degrees, which is the angle X. So angle X is 60 degrees, which is answer number 2. So property in this, what is the property you are being tested in this question? Angle at the point is 360 degrees. All right. Okay, question number 7. Now, the average of 6 numbers is 103. The sum of 5 of the numbers is 430. What is the value of the 6th number? Now, if you are confused, you don't know how to do, then think of how to draw a model, which is the average model. So draw the first sentence, the average of 6 numbers. So what is average? It means that every number is the same, right? So you have 103. See, every number is the same, but is that their real numbers? No, it's not their real numbers, right? It's just that everyone is the same. That's average. And immediately you can find the total. So once you have the average, you can find the total. You take 103 and you times 6, and you'll get 618, which is the total. All right, the sum of 5 numbers. So what you do, so you can draw the same rectangle again, because there are 6 numbers, right? And 5 of the numbers. So yeah, 1, 2, 3, 4, 5, something like that. Okay. So the sum of the 5 numbers will be how many? Will be 430. So can you find the last number? What is the last number? So you take 618 and you minus 430, and you will get the last number, which is 188. Okay, that's the last number. So answer number 1. So average model, right? If you do not know how to do. Okay, question 8. The figure is made of cubes of h 1 cm. So h means every side. Every side is 1 cm, right? Every side. So can you find the volume of 1 cube? So if every side is 1 cm, then the volume of 1 cube must be 1 cm times 1 cm and times 1 cm, because length times height, or length times breadth times height to give you the volume, and you get 1 cm cube. All right, you want the figure to have a volume of 36 cm cube. So you need how many cubes? So 36 cm cube will be how many cubes? So you divide by 1 cm cube, right? The volume of one cube. So that will give you how many cubes? That will give you 36 cubes. So you will need 36 cubes to make a figure, right, which has a volume of 36 cm cube. Then you count the figure over here, and how many cubes do you have inside? So you look at the column, right? Count by the columns. So for example, there's one cube here, and there are 2 cubes in this column. Then there are 3 cubes in this column, and then 2 cubes again, 1 cube and 1 cube. So how many cubes make this figure? So you count, there will be 3, 5, 6, 7, 8, and 10. So you have 10 cubes only, but you need 36 cubes to form the figure, right? To form this figure that you want. So how many more must you add to get 36 cubes? So you have to minus 10. All right, because in the figure on the diagram, you can see there are only 10 cubes that make up the figure. So you minus 10, and you will need another 26 more cubes. So the answer is number 2. Okay, all right, question number 9. Shortcut, all right, shortcut. Jane had $30 at first. She spent $24 on the box of chocolates. What percentage? Shortcut, when you see the word percentage, you change the question into what fraction. So you write as a fraction, then you convert to percentage, because that'll be much easier. So what fraction of her money? So her money is $30. Had Jane left. So Jane must have 30 minus 24. She has $6 left. Okay, now how to get the percentage? You make the denominator into 100. But over here we have a problem. So because 30 cannot become 100, so you always get the simplest form. Always try to use the simplest form to get your denominator 100. So divide by 6, you get 1/5, which is the simplest form. And then use the denominator now to get 100. So 5 times 20 and 1 times 20. So you have 20 over 100, which is how many percent? Which is 20% of the money was left. So your answer should be number 1, right? 20% of the money was left. So that's a shortcut, right? Then you don't have to do so many steps. Okay, question 10. There were 80 books altogether. 24 books were fiction books, and the rest were non-fiction. What was the ratio of the fiction to the non-fiction? Ratio method. What is ratio method? It means that you label the ratio. Okay, label the ratio like this. Okay, you have fiction is to non-fiction and total. So you will need to clarify. You need to be very clear in the label, right? You must specify, or you must know in your ratio, you must have all the different types of books in your ratio. That's how you label. And the total books is 80, and there are 24 books non-fiction. And how many non-fiction? So 80 minus 24, you will get 56. So what was the ratio of the fiction to the non-fiction? Then you must get your simplest form. So you try to divide by something bigger. Don't divide by 2 because it's a bit slow. So you can actually divide by 8, right? See whether you can divide by something bigger, and you will get 3:7:10. So what's the ratio of the fiction to the non-fiction, which is 3:7. So your answer is number 1. Okay, so these are all your 1-mark questions, and supposedly to be quite to be easy to score. So now we go to the 2-mark question, all right? And it gets a little more steps. Okay, so let's look at question 11. Okay, what is the missing number? Now this seems to be quite easy, but may not be. But how do we do? You have to get the answer here first. So what is 2142 divided by 20? Now, it's very hard to divide by 2-digit number, so you should break up into number bonds, right? 20 is 2 and 10. So divide by 2 and then divide by 10. Then you get the answer here, which is 2142 divided by 2, and you get 1071, and then divide by 10. And how to divide by 10? You change the whole number into a decimal, then you shift the decimal point to the left 1 time, and now you have 107.1 because the decimal is now above the arrowhead. So 107.1. So after you divide, this is what you get, which is not the answer. And then 107.1 is equal to what times 10? Then what do? Then you take 107.1 and divide by 10 to get the missing number, right? Okay. So again, you shift the decimal point to the left one time, all right? And that will be 10.71. So what's your answer? That will be number 3, because after shifting, you will have 10.71. Okay, so that's how you work out this complicated statement, right? You break out into number bonds, and then shift decimal point, right? Okay, question 12. Now, question 12, how do you find the shaded parts? Okay, you will need to find the base and the height of the shaded triangle. So look at this triangle. What is the base? What's the height? Before you can do that, you must know the unknown side. So you can see that there are some sides that are equal, FG equal to GA. That's why you see the marking. And when you see the markings, it means what? It means that they are the same. So 16 divided by 2, 8. Here also 8. Here also 8. Okay. All right. And then what else? And then you can see that we can find what? We can find the area of this triangle. Okay, so how do you find the area of this triangle? Because this is also 8. So you actually have what? You have a square, right? A square. So a square means all sides are the same. So you can find the area of the red color triangle. So you always start with half when you want to find the area. So half times base and times height. So when you find area of a triangle, you must always have the half in front, and then you divide by 2, and then divide by 2. And then you have 4 times 8, right? 4 times 8 will be 32. That's the area of the red shaded triangle. Okay, let's look at the other shaded triangle, which is over here. So how do you find the shaded triangle? So you have half times base, and the base will be 8 plus 8, which is 16, and the height will be 8. So you cancel divide by 2, and 16 divide by 2. So now you have 8 times 8, that will be 64. So that will be the black color area. Okay, so now can you find the total shaded area? So you take 64 plus 32, and you get 96 centimeters square. And that's the shaded area, answer number 2. Okay, so for this question, you have to know how to find the height and the base, all right? And they are always right angle. Height and the base are always right angle. Just look for 2 lines, they are right angle to each other, and you should be able to find the base and the height easily. Okay, let's go to the next one, question 13. Okay, in the figure, ABC is an equilateral triangle, so you should be marking out the sides they are equal, and you should also be putting 60, 60, and 60 before you do any solving. And then AB is equal to BD, so mark out the sides. Right? You need to mark out the sides so that you can recognize you can see the isosceles triangle, which is 2 sides that are equal in the isosceles triangle. And then the last thing to do is to put the question mark, which is angle DAE. So this is the question mark that you're supposed to find. So how do you find the question mark? Okay, let me just put nicely. So this is the question mark. Okay, now once you have marked out all these things, you have put all these important numbers and question mark and the markings into the diagram. Then the next step is to look for an easy angle. Angles that are easier to find. So this angle must be 120 degrees because angle on a straight line, right? What straight line? This straight line is 180 degrees. Then is there a triangle? There is a triangle which is isosceles that you can see over here. So can you find the 2 angles that are equal? So these 2 angles are equal because it's an isosceles triangle. So you take 180 and you minus 120 and then divide by 2. Divide by 2. And what do you get? Okay, let me just erase that. So one more time, sum of angles in the isosceles triangle minus 120, and the answer divided by 2, and you will get 30 degrees. And you put down 30, and here also 30. Okay, all right. Now, how do you know which two angles? How do you know which two angles in the isosceles triangle are equal? Some of the students are confused, right? Because you don't know which two angles are equal in the isosceles triangle. You just have to look at the two sides, they are equal. Look at these two lines, they're equal, and put your finger, right? Put your finger at where they meet, okay, where they meet, right, at this corner. Then use your fingers to trace the line. Trace the line, trace your finger to the end of the line that's equal, and the angle at the end of the line that is equal will be the same. Okay, so how do you recognize the two angles that are equal? You have to put your fingers on the two sides that are equal and trace it all the way to the end of the line, and that's where you have the angles, they are the same in the isosceles triangle. Okay, and now can we find the question mark? Yes, we can, because I can find this other angle. So 180 minus 30, I get 150 degrees. And then I have another triangle, which is the black color here. And I can now find the question mark already. So how do I do that? I take 180 minus 150 and minus 18. Okay, so let me write down 180 minus 150 minus 18. And what angle is that? Okay, let's work out, and you will get 12. Is it 12 degrees? Let me see, 12 degrees. Yeah, the answer is 12 degrees. So this question mark is 12 degrees. So answer will be number 1. Okay, question 14, right? 14. Now, a pole is 7/10 meter long. 1/5 of it is painted blue and the rest is painted green. What is the length of the pole that's painted green? So again, very common mistake. Some of you must have taken 7/10 minus 1/5. So again, cannot. Why cannot? Because the two fractions are not the same. There's a meter here, but there's no meter, right? There's no meter in front of 1/5. So these two fractions are not the same, not talking about the same thing. So what should you do? You should find how long is painted blue. What is the length of the pole that's painted blue? 1/5 of each. Okay, can you see the fraction here? 1/5 of, so what is this 1/5 talking about? Talking about the each, which is the pole. So 1/5 of the pole, which is 7/10 meter. So how long is 1/5? Then you work out. So 1 times 7 and 5 times 10. So how long is painted blue? So 7/50 meter of the pole is painted blue and not 1/5. Okay, all right. So that is painted blue, which is 7/50 meter. Then now you take 7/10 meter minus 7/50 meter. Now you can minus the fractions because the fractions now have meters in front. So they are the same. So you make the denominator 50, 10 times 5, 7 times 5. And now you can minus the other fraction. So 35 minus 7 will be 28/50 meters. But the answer, there's no answer options there. So which means that you have to simplest form. So 28 divided by 2 and 50 divided by 2. And what is the length of the pole that is painted green, which is 14/25 meter. So answer number 3. Okay, so by now you should be very expert already, right? That you know that you cannot minus the fractions because they are different. Okay, they are not the same. Okay, next one. The next one will be your grouping method. Okay, so when I look at the next question, there are clues that tell me what method to use, like a list of numbers. That is a grouping method because I can start the group with 2 and ends with 2 again. So that's one group. Then 2, 7, 4, 0, 2, another group, and so on. Okay, so you can see that I have same groups, right? Repeated groups. Okay, grouping method. So what is that? Is to find how many groups. Make one group and then find how many groups. So if one group got 5 numbers, there are how many digits altogether? There are 113 digits. So 113 numbers or digits, and you divide by one group, there are 5 digits. So you take 2 times 5 is 10, then you minus and you 3, and then 2 times 5 is 10 again, and there's a remainder 3. Okay, what does that mean? It means that there are 22 groups and there are remainder 3 digits left over. So the remainder is not enough to form a group. So what are the 3 digits that are not enough to form a group? So your group starts with 2, then 7, and then 4. So this will be the last 3 numbers or the remainder 3 numbers. So what is the 113 digit, which is the last digit that you see? And that digit is 4. Okay, so that's how you do grouping method, right? Grouping method for this question. Okay, let's go to the next question. All right, so now we come to the 1 mark. Okay, the 1 mark question. So this is your 4 operations. So what do you do first? Okay, I think there's a plus here. All right, this is a plus. All right, so what do you do? So you have 3 times, all right, there's a bracket. So you must do the bracket first and copy down the rest the same. So you do the work out the answer in the bracket, which is 18. All right, 42 minus 24 is 18. And then you must copy down whatever you see. Right, so you do step by step. So now you have times, divide, and plus. So you must do the times first because it's the same as divide, right? Equally important as divide. So you do whichever comes first, right? Times and divide, do whichever comes first. You get 54 and then divide by 2 and then you plus 7. All right, so what do you do now? You do the divide because divide is more important than plus. So 54 divided by 2, you get 27 plus 7, and that's how you get your answer 34, right? 27 plus 7 is 34. Okay, so that's how you do the 4 operations. Okay, now next one, question 17. The area of a rectangle is 78 cm square and the breadth is 5 cm. What is the length of the rectangle? And your answer must be a mixed number in the simplest form. All right, so to find area of a rectangle, you must have length times breadth equal area of rectangle. So what's the length? The length, we are not sure. Okay, the length. But what's the breadth? The breadth is 5 cm. And what's the area? The area is 78 centimeters square. So to get the length, you must take area divide by breadth. So you take 78 and then divide by 5. So 1 times 5, then you minus, pull the 8 down. And then 5 times 5 is 25. And there's a remainder 3. And don't continue dividing, because if you continue dividing, you get a decimal. But you want your answer to be a mixed fraction. So your answer will be 15 and 3/5 centimeter, which is the length of the rectangle. Okay, all right, question 18. Tina is 1.48 meters tall and she is 16 cm taller than Mary. So what is Mary's height? Now you cannot take 1.48 meter minus 16 centimeter because they are not the same units. You have to change them to be the same unit. So you look at the answer. The answer is in meters, right? It's in meters. So I would like to change the 16 cm into meters. So how do I do that? So 16 cm is how many meters? So from small to big, you have to divide. From small unit to big unit, you have to divide by 100 because 1 meter is 100 cm. So change the whole number into a decimal and then shift the decimal point to the left, 1 and 2. And where's your decimal point now? Over here and 0 in front. So after you divide by 100, you will get 0.16 meter taller than Mary. So Mary is how tall? Then you take 1.48 meter and minus 0.16 meter, right? To get how tall is Mary, because Mary is shorter. So you have to minus, right? To get Mary's height. Okay, so 1.48, if you do your working correctly, your answer will be 1.32 meter. Okay, so Mary's height is 1.32 meters. Okay, let's go to the next one, which is a fraction problem. So Mr. Ong bought 28 fruits. 2/7 of them were apples. How many apples did he buy? So what is this fraction generally talking about? This fraction is generally talking about the word them. And what is them? All the apples. So which means that if I were to draw a model, even though it's a very simple problem, no need to draw a model, but if I want to draw the model, how do I draw? It means that this 2/7 is talking about the fruits, generally talking about the fruits, right? So whenever you see fractions, you will need to ask, what is it talking about generally? It's talking about the fruits. Then you draw a rectangle for the fruits and cut into 7. So now specifically, right? Specifically, how do we draw the fraction? How do we interpret the fraction specifically? The total number of fruits is 7 units. And 2 units were apples. So this is your specific, all right? This is something very specific already, right? If you want to break apart the fraction, this is how you break apart. The 7 is the total, right? The total of all the fruits, and the two units are apples. But if you want to talk about generally, this fraction is generally talking about what? It's talking about apples. talking about the fruits, right? It's talking about all the fruits here. So we need to understand when you read the question, when there are fractions in the problem, you will need to know what is it generally talking about, because that's very important. Because if you have a few fractions in the same problem, that is going to be very useful. Because if they are talking about the same thing, then you can plus or minus them. You can make the denominator the same. But if the fractions, right, if the fractions in the problem, they are not talking about the same thing, then you cannot make the denominator the same. But this question is very easy because it's only one fraction. All right, so if 2 units were apples, then the rest must be the the non-apples. All right, and she bought 28, or Mr. Ong bought 28 fruits, and every box is a unit. So how many apples were there, which is the question mark. So of course, it's very easy that we don't need to draw a model. Okay, but I will still draw a model, all right? Just to show you how to break apart the fraction. So 7 units is 28, and then 1 unit will be 28 divided by 7. So 1 unit is 4, and there are 2 units of apples. So 2 units will be 4 times 2, and that's how you get 8 apples, right? Okay, yeah. Okay, question 20, last one. And the last 1 mark question. All right, read the whole question. You have 2 straight lines. So when you have straight lines, you look out for what? Look out for x, because the 2 straight lines can cross each other to form x. And when there's an x, then you have vertically opposite, all right? Vertically opposite angles, which are the same. All right, but before that, where is the question mark? So remember to put the question mark, which is here, M-O-R, all right, M-O-R. So how do you know that is the question mark? How do you know? All right, some of you you are unable to recognize the angle that you're asked to find. This is how you recognize M. Then you follow the line O, R. So the angle is where? The angle is between the 2 blue lines, right? Or the angle is found near what? Near the middle letter, right? O. Okay, the angle is found near the middle letter O. So those of you who have a hard time trying to know what angle that you're trying to find, the angle is near the O, all right, which is a question mark. Okay, so I'm going to just take out the blue color again. So once you have 2 straight lines and you have put the question mark there, then you will see that vertically opposite angles are the same. 42, and then here will also be 42, right? 42. So this angle here is 42 degrees. You just have to minus 14, right? So 42 minus 14, and you get 28 degrees, which is the question mark, right? So when you see 2 straight lines crossing each other, you look for vertically opposite angles, right? Which are equal, right? Vertically opposite angles are equal. Okay, let's go to question 21. All right, 21. So this one looks like easy, but may not be that easy. Okay, so this will test you on your shifting of decimal point. So 87.6 divided by what will equal to what? Equal to 0.0876. Okay, so is it divided by 10? Let's try. So if you divide by 10, you shift the decimal point to the left, which is 1 time. Shift after 1 digit, you will get 8.76, which is not what you want. So is it divided by 100? Then let's shift 1 more time to the left. And now your decimal point is here, right here. And that'll be 0.876, which is also not what you want. Then is it divided by 1000? Then you shift 1 more time to the left again and put a 0 here. All right, there's an empty basket, and the arrowhead put a decimal point, and then put the 0 in front of the decimal point. And what do you get? You will get 0.0876. So what is the question mark? The question mark is divide by 1000. Okay, so you are tested on how to shift the decimal point to the left. When you divide, you shift to the left. When you times, then you have to shift to the right. So you shift to the right 1 and 2. Because there are 2 zeros, and put the 0 in the empty basket and the decimal point above the arrowhead, and it will be 340.0 after multiplying. So your answer will be 340.0 or just 340. So you can leave out the 0.0 because it's the same as 340. Okay, question 22. Looks it's a story sum. So Edwin, Nicholas, and Andrew each has some stamps. Edwin has twice as many stamps as Nicholas. Nicholas has 4 times as many as Andrew. And if Nicholas has 36 stems, how many more stems does Edwin have than Andrew? Two methods, right? Two methods to solve. You can draw model, all right, model, or you can use a ratio method. But this question is there's no ratio inside, right? There's no ratio in this problem, but ratio is a method, right? So I can still use the ratio method to solve this non-ratio problem. That's why Mr. Ong said ratio is a method. All right, so let's look at this non-ratio problem and how do we use the ratio method. Now, the first sentence, we can't write anything, but the second sentence, Edwin has twice as many as Nicholas. 2:1, twice, right? Edwin has 2 times, Nicholas has 1 time. And then Nicholas has 4 times as many as Andrew, 4:1. Okay, and then you look at these 2 ratio and you compare. Do you see something or do you see something similar? You can see the Nicholas and the Nicholas, same person, but the numbers are different. So you have to make them equal. So you times 4 and you times 4. And then what do you get? You will get 8:4. And once you make Nicholas to have equal already, then you can call them the same units, call them the same surname or whatever. All right, so they become one big family. But before you make them equal, they are actually called parts and units before you make them equal. But once you make them equal, then they become units. All right, they become one big family. All right, and you can ignore the old ratio. And you look at the units ratio. Okay, look at the units ratio. So, and then you can see that, what can you see? Nicholas has 36 stems, which is 4 units, right? So 4 units is 36 stems. Yep, because Nicholas has 4 units. So 1 unit will be 36 divided by 4. And how many more stems does Edwin have than Andrew? So you look at Edwin. Edwin has 8. And Andrew has one unit. So how many more units? So there'll be 7 units more, right? 8 minus 1, 7 units more. And that will give you 9 times 7, which is 63 more stems. And that's how you get the answer using ratio method. So ratio is a method. Okay, it's a method, right? So you need to think of whether you want to draw a model, which is possible, or you can also use ratio. Okay, let's go to the next one. And this time the problem is a ratio problem because you can see there's a ratio sign. Okay, there's a ratio sign there. Okay, so Zini, Yan, and Zani share a box of chocolates. Zini and Yan receive the same number of chocolates. And the ratio of the total chocolates Zini and Yan receive to the total chocolates Yan and Zani receive is 8:15. What was the ratio of the chocolates Zani received to the total chocolates in the box at first? Now it's a bit confusing. But because this is a ratio problem, then what's the method? Ratio method, right? You want to draw model also can. I can also draw model for this. But sometimes model drawing takes time. Right, so what is the best? What is a better alternative? Ratio, right? Ratio to solve this problem because it's already a ratio problem. Okay, so how do we use the ratio method? You have to label. Okay, label your ratio. So Zini and Yan receive the same number of chocolates. So how do you want to write as a ratio for this sentence? You can do something like this: receive the same, 1:1, right? Equal number. They have equal number of chocolates. And the ratio of the total chocolates, Zini and Yan, all right? So these 2 persons add together to the total number of chocolates, Yan and Zani, right? And then what's the ratio? So the ratio is 8:15. Okay, so there are different ways to label your ratio. It's up to your model drawing, your creativity. All right, but the most important thing about ratio method is you need to label everybody's name. You need to make sure that all the names are inside. So you cannot miss out any name, because once you miss out any name, then it's very hard to compare. Because after I've written down these 2 ratio, then I can compare already because I got all the names there. So how to compare? Very easy. You can see that Zini and Yan together, they have 2. And then you look at this one, all right? Look at this. The same 2 person, they have 8. So there's a different number, right? But same 2 person, but different number. So can I make the 2 into a 8? I times 4. Okay, I 2 times 4 and I will get 8 as well. So this whole ratio, I times 4. And then what will happen? and then I will get 4 is to 4 is to 8. Okay, and once I have made them the same number already, then I can call them units. They are all units family, right? Units family. But before you make them the same, they are called parts and units family, right? Parts and units, different before you make them equal. But once you make them equal, then they are units family already. Okay, so I can cancel this one and just look at the units ratio. So what is the ratio of the chocolates Zani received? So Zani has how many? So Zani, where's Zani? So okay, so can we find Zani? Let's see. Okay, you have Zini 4 unit, and then you have a Yen also 4 units, and then this is Yen also 4 units, and then Zani must be 11 units. See, that's why when you use the ratio method, you have to make sure that you label every name is indicated. You have indicated every name in the ratio, because once you miss out any names, you'll find that you are stuck, you're confused, right? So in my ratio, it's clear because all the names are there. Okay, all the different people names are there. Okay, so what's the ratio of the chocolates Zani received, which is 11, right? 11 to the total chocolates at first. Okay, so what's the total chocolates? So you take 11 plus 4 and plus 4 to get the total number of chocolates. So 11 plus 4, 15, 15 plus 4, 19. So there are 19 units of chocolate altogether at first. Okay, that's ratio method. Okay, let's go to 24. Right, find the area of the shaded parts. If you look at the shaded part, you find that it's very hard to find the area because there is no base. You can't find the base. You can't find any number on any side of the triangle. So what do? Then we look for other regular shapes to find their areas. So if you look carefully, when you have area and perimeter, there's something called spatial visualization. It means that you must be able to recognize different kinds of shapes. So if there's a shaded triangle, is that the only shape that you see? No, I see a big square. All right, there's a square given, and there are also other triangles. So if I cannot find the shaded triangle, then I work. What do? I focus on the other shapes, the other triangles which are not shaded, and I also focus on the square because I can find the area of the square and minus away all the unshaded triangles, and I get the shaded triangle. All right, so let's find the area of the square. So square is all sides equal. So you take 10 times 10. So the area of the square is 100. Okay, so how do you find the area of all the other triangles? Okay, all the other triangles that are also right angle triangles. So when the triangle is right angle, it is actually very easy to find the area as compared to a triangle that's not right angle. Because once you have a right angle triangle, the base and the height can be recognized easily, right? Because they're always perpendicular to each other. So okay, so can you see the markings here? So it means that they are equal. So the base and the height is half times base times height. And that will give you the area of the black triangle that you see. So 4 times 4, 16, 16 divided by 2. So that's 8 cm square. Can you see another right angle triangle? And I can also find the base and the height. The height is 6. So the base is 10. So half times 10 times 6. So 10 times 6, 60, 60 divided by 2, 30, or you cancel, and you also get 30. Okay, and then can you see another triangle here, which is also another right angle? So what's the base? The base is 6, and the height is 10. So same, half times 6 times 10, and you get 30. So now how do you find the shaded area? You add up all the unshaded. So you have 30 plus 30 plus 8, that will be 68. Then you take 100 minus 68 to give you the shaded triangle, which is 32 cm square. Okay. All right. So if you can't find the shaded triangle, then your eye must be able to see other kinds of shapes, which are which have to be regular. So you have to always look out for regular shapes. All right, shapes, what kind of regular shapes? Triangle, squares, rectangle, circles, semicircles, all these are regular shapes that you will need to look for. Okay, look for. Okay, let's go to number 25. Okay, we are coming to the end soon. Okay, now in a day, Jamie spent 1/4 of the day in school and 1/12 of the day doing her homework. Now this problem gets some students confused, okay, because there are two fractions there. So when you see fractions, you need to ask, what are they generally talking about? So 1/4 is talking about the day. And the other fraction is also talking about the same day. So they are talking about the same group. So you have to make the denominator the same. So you have 1/4 and you have 1/12. So you make them to have the same denominator. So 3/12 and 1/12. All right. Okay. So then how much time did she spend altogether doing her homework and in school? Then you add them together, 3/12 plus 1/12, or let's use the model, okay? Because since I should use the model, because fractions means we can always draw a model. So let's draw the model, and this 1/4 is actually talking about 3/12, and it's talking about the day. So the day, okay, the day cut into how many boxes? So now you break apart, okay, break apart. So this is how you break apart the fractions. But before you break apart, what is it talking generally about? It's talking about a day. And then after that, break it apart to draw your model. So the day has how many units? 12 units. 6, 7, 8, 9, 10, 11, 12. And 3 units of the day are spent in school. And 1 unit of the day is spent doing homework. Right? So how many hours did Jamie spend in school and doing homework together? Question mark. All right, so 1 day. But where are the hours? Day, this in terms of day. Then how do you relate to hours? Because 1 day is how many hours? Every day is how many hours? Then your mind must think 1 day is 24 hours. So if 1 day is 24 hours, that will be 12 units. Okay, so your 12 units is 24 hours, 12 units. Then your 1 unit must be 24 divided by 12. And there are 4 units, okay, 4 units spent in school and doing homework, okay? So there are 4 units spent in school and doing homework. So that will be how many hours? That will be 4 times 2. So she must have spent 8 hours in school and doing homework, okay? So that's how you draw the model, and then use the model to show the unit statements. And then with the unit statements, you work out the answer. Okay. All right. So 1/4, 4 times 3, 1 times 3. Okay. So that's how we do. All right. Mr. is just having a quick check to make sure that there is no mistake. Right. No mistake in this answer. Okay, but I think everything is correct. Okay, let's go on to the next one. Question 26. Okay, Molly formed a rectangle using a piece of wire, and the breadth of the rectangle was 1/6 meter, and the length was 3 times as long as the breadth. What was the length of the wire? And give your answer as a mixed number in the simplest form. Now, there is a method which is to draw a diagram, because some of you make a careless mistake, which I will show you later. So when you draw a diagram, you'll find that the breadth is 1/6 meter. And how do you find the length? The length is 3 times as long as the breadth. So you must take 3 times 1/6 meter. And that will give you what? So you change the whole number into a fraction, and then you cancel, divide by 3 and divide by 3, and you 1 times 1, and then 1 times 2. So you multiply the numerators, and then you multiply the denominators to get half meter. So the half meter is the length. So what is the careless mistake? Now the careless mistake is because you didn't draw the rectangle, you take 1/6 meter plus half, and that's the answer already. But that's not true, because you need to add another 1/6, another half meter, because the wire is the parameter of the rectangle. What is the wire? The length of the wire. What is the wire? How long is the wire? the length of the wire is actually the parameter of the rectangle, which is the black line that you see, right? The black lines, okay, that forms the rectangle. Okay, so how do you add up all the sides? Half plus half plus 1/6, and then plus 1/6. So make the denominator all the same. So 3/6 plus 3/6 plus 1/6 and plus 1/6. So once you make the denominator all the same, then you can plus them all together. 3 plus 3 is 6, plus 1, 7, plus 1, 8. So you have 8/6 meter, and change it to mixed number. So how to change it? You take 8 and then divide by 6, and that's how you change it. And then you have 1 and 2/6 meter, but your answer has to be simplest form. So 1 whole, so 2 divided by 2 and 6 divided by 2. So what is the length of the wire? The length of the wire is 1 and 1/3 meter. Okay, so there's a simple method here is to draw a diagram. Then you will know how to find the length of the wire, which is the parameter of the rectangle. Okay, let's go to question number 27. Percentage. This is a killer question, right? Some of you may not know how to do this. The fruit seller had 260 apples and 370 oranges. 10% of his apple. Now, every time there's a percentage, right? There's a percent. What is it? Again, like fraction. What is it generally talking about? It's talking about the apples, right? Look at the off, right? The off. It's talking about his apples, which is all the apples. And all the apples must be 100%. Out of all these apples, 10% are rotten. And then the other 20% is generally talking about what? It's talking about his oranges, right? And which is all the oranges. And all the oranges is 100%. So out of this 100%, 20% are rotten. That's how you need to interpret, right? And are these two percentages talking about the same thing? No, they are not talking about the same. So when it's like fractions, when you see fractions, you have to ask what are they talking about? So are they talking about the same type of fruits? They are not. Then why do you take 10% plus 20%? Right, and then 100% minus 30? That's wrong already. Because you cannot take 10% plus 30%. Why? Because they are not talking about the same thing. So what should you do? Then if the apples is 100%, that will be 260. Shortcut. Okay, what's the shortcut? I want to find how many apples are not rotten. So I will need to know that will be 90%. That will be 90%, right? Because 100% is the apples. You minus away 10% that is rotten. You get 90% not rotten. So shortcut. What's the shortcut? The shortcut is to jump. Instead of finding 1% is how many, I can divide by 10 to get 10%. Then later I jump again, I times 9. Then the other side, I also follow. Divide by 10 and I will get 26. And then later I jump, I times 9. So what is 26 times 9? So 26 times 9 will be 234. So I got 234 apples not rotten. Okay, that's a shortcut. Then go to the oranges. Okay, oranges, they are 100% again, which is all the oranges, and that is 370 oranges. And if 20% are rotten, then 80% must be not rotten, right? 100% minus 20%, you get 80% not rotten. Shortcut, I can do the same thing. I don't have to find 1%. I jump, I divide by 10 to get 10. And then later, I times 8 to get 80%. All right, so the other side, you also divide by 10 and you get 37. How do you get 37? Because when you divide numbers with zeros, you take out 1 0 and take out 1 0. So 10% is 37. Okay, 37 divided by 1, 37. Then later you jump again, times 8. So 37 times 8, you get 296. So you have 296 oranges not rotten. So how many fruits were not rotten altogether? Then you take 234 plus 296, and that will give you the total fruits that are not rotten, which is 530. Okay, So that's how you do your percentage. Okay, question 28. Every time you see an age problem, it's always a before and after. Right? If you see an age problem, like the ratio of Gary's age to Harry's age is now, right? Can you see the word now? That is at first. All right, it's 3:2. 8 years ago means past. So it's like a before and after, right? So you have now and past. So Gary was 10 years old. How old is Harry now? So when there is an age problem, right, and it's a before and after problem, then there are two methods: model, drawing, or the table. So in this question, I will show you the table method. So I can even change the BCA, right? I can change the BCA, B for before, A for after. I can even change this to what? Now and past. That will be more relevant. Okay, more relevant. So you can be creative, right? You can make it more relevant, now and past. Okay, so then you must have to use this table, you must have 2 persons at least to compare. If there's only 1 person you cannot compare, then you can't use this table. And then there's a total. And because it's a before and after problem, you will need to ask what is unchanged, right? We have talked about that many times already. What is unchanged? Total unchanged, 1 person age unchanged, the difference unchanged, or everything changed. Now, because this is an age problem, so the age difference is always unchanged. Okay, so there'll be an extra column for the difference. Okay, then put the numbers inside. Gary to Harry, 3:2, and that's units. And then total is 5 units. And what's the difference? The difference is 1 unit. Okay, and 8 years ago, you have to minus 8 because it's in the past. So minus 8, Gary was 10 years old. So this is the actual value, 10 years. So how old is Harry now, which is the question mark? And your model and your table is done already, right? And when your table is done, you should be able to use your table to solve without looking at the question. So how do you use your table to solve? Now, there are a few things to learn about this table, right? The table can work backwards, can flow backwards like this. So when you work backwards, 10, the minus 8 become plus 8, that will be 18. So Gary must be 18 years now. And the table, what else can you learn? When there's a box here, it means that they are equal to each other. So that means that your 3 unit is in the same box as 18. So they are equal. So your 1 unit is 18 divided by 3. Then can you find Harry's age? Harry's age is 2 unit now. So 6 times 2. So Harry must be 12 years now. Okay, that's your table method. And do I need to know how old is Harry in the past? No need. Do I need to know the total age in the past? No need. So once you got the answer ready, you can just leave out the boxes empty. Leave the boxes empty. Okay, let's go to the next one. And okay, question 29. Okay, looks a bit wordy, but wordy problems doesn't mean that they are always hard to understand. It's the same thing. When you see fractions, you still need to ask the same thing. What is it talking about? So the table shows the range of scores of all the participants in the first round. A higher score means that a better performance. For the first round, the top 1/4. What is this fraction talking generally about? It's talking generally about the participants. Okay, which is all the participants. So 1/4 will allow to move on to the next round. So what was the minimum score that a participant obtained to move to the next round? So 1/4 is generally talking about the participants. So if you were to break up the fraction and draw the model, it means that there must be a rectangle, right, which is all the participants, and then you cut it into 4 units, because when you break up the fraction, it will be something like this, right? So there are 4 units or 4/4. Okay, 4/4. Okay, so if there are 4 units, okay, let me just erase the model, because sometimes you don't always have to draw model when you understand how to look at the fraction. So the participants, which is everybody, must be what? Must be 4/4 or 4 units. Okay, 4 units. Okay, so let me just use a different. Okay, so this is 4/4. All the participant is 4/4, which is how many people? How many people are there all together here? So you add up the numbers. So you have 5 plus 35 plus 35 plus 13 plus 12, which is 100. So there are 100 participants for this for this competition, right? And that is your 4 units or 4 quarter. Okay, 4 quarter. So 4 quarter is 100 participants. Then 1 quarter or 1 unit will be how many? Will be 25 participants because 100 divided by 4. So there are 25 participants who went through the first round or who go on to the next round. So where are the 25 participants? Can you see the 13 and the 12? When you add them together, these are the 25 participants who move to the next round. So what's the minimum score to get to the next round? Look at 16 to 20. So the lowest score must be 16 marks. So the minimum score is 16. All right, got it? Okay, question 30, the last question. Now, again, okay, there is a type, there's a picture error. So this is your 210 degrees. Okay, now for this question, there is a shortcut. Okay, shortcut, which I'll show you later. So, but before that, you need to read the question, and ABCD is a square. You need to show the markings. Okay, show the sides, they are equal. And then DEFG is a trapezium, and you need to show the arrow sign. These arrow signs are indicated by the students. So on the actual drawing, on the exam paper, I don't think there was an arrow sign there. So you have to put the arrow sign there because you will find a shortcut from here. All right, okay, so later you will see what's a shortcut, and ADE is a straight line. So there is a straight line, which is very important because angle on a straight line is 180 degrees. So you need to know whether it's a straight line or not. All right, sometimes it looks like a straight line, but because the question number says, you cannot assume. All right, sometimes it looks like, but it is not. Okay, and then you CDG is 210 and find angle FED, which is the question mark. Okay, so what do you do? Now, this is a square. Square has right angle, and so can I find this angle, which is over here, this angle? Okay, how to find the angle? Angle at the point, which is 360 degrees, minus 210 and minus 90. Okay, angle at the point means all the angles add together is 360 degrees, and you minus 210 minus 90, you will get 60 degrees. And what's the shortcut? So that's the reason why you need to put the arrow sign, because when you put the arrow sign, you will see something. You will see a special letter. Now in angles, in geometry, right, in your angles, in triangles and quadrilaterals, there are some letters that you have learned. Letter X. Okay, when you see two straight lines cross each other, there's a letter X. Then you have vertically opposite angles, they are equal, right? Letter X, okay, very important letter, very common letter. Letter Z, when you have two lines that are parallel, right? So these two angles are also the same. So you only have letter Z when you have two lines parallel. And then there's one letter, which is the letter F. So you have letter F when you have two lines, they are also parallel. Then you have letter F, okay? But this Z and this F, it doesn't have to look like that. It could look something different, like the Z could be something like this. This is also a Z, but it's a different kind of a position, right? The letter F can also be a different kind of position. I mean, you can, the way you see the F is like it's upright, but your F can also be upside down as long as it looks like a F when there are two lines that are parallel. Okay, so as long as there are two lines that are parallel and it looks like a F, then that is your letter that you can see. So let's come back to this question. Do you see a letter F in this diagram? There are two lines that are parallel, right? These are the two lines that are parallel. So do you see a letter F that is a bit lying down? That is also a letter F. And once you see a letter F, then this is 60. This one also 60, because the two angles look identical. They are similar. So your question mark is 60 degrees. Okay, so we come to the end. All right, come to the end of this paper one lesson, which is another 1 hour. So next time when we do our, okay, just a reminder to all my students who are watching. So if you are online on Monday, please remind me to do recording, all right, to press a button to record the lesson. All right, then you will have something to watch. Otherwise, Mr. Ong has to run through the lesson again just to give you the recorded lesson. So you will need to remind me, all right, before we start the lesson to start recording. All right. Okay. So so you need to add up your marks, right, and see how many marks you get. And the more we do, okay, the more we do, you should be getting better because the mistakes should be getting lesser and lesser. All the common mistakes, it should be getting lesser and lesser because you should have understood your concept better. You should have understood your basic better now, right? And that's how you do well in the paper one. Right, so I will send out the next paper one. Our email, or not email, I will send to you the next school paper a few days later. And next coming Monday, we will do the same thing. All right, so you will need to do the paper first. No calculator, try to do it in 1 hour's time. And then next Monday, we will run through the questions again. And this is what we will do for every Monday. All right, okay, so that's the end of this paper one lesson. I will see you on Monday, right? This coming Monday at 8 p.m. All right, see you next Monday.